So, a term that often gets brought up in politics is centrism. Now, technically, you could use this term in other areas as well. Really in any subject, even medicine or science or philosophy. There's all sorts of ways to be a centrist. But see, usually when this term is thrown at somebody or a specific ideology that a group of people holds, usually it's meant as an insult. Now, we have a positive, or at least more positive version of the term centrism, which is the word moderate, right? So when we want to say that something is holding a sort of middle ground position and that is a good thing, we tend to call it like a moderate position. But when we want to highlight that it's a bad thing, right? Like in certain cases where it's actually bad to hold a middle ground position, instead of calling it a moderate position, we call it a centrist position. And I don't know if you're one of the people who has ever wondered what the difference is, right? Like, how do we determine when a middle ground position is good or when it's bad, right? Isn't a middle ground position just a middle ground position, right? So, like, how do you tell when it's a good case to hold a middle ground position or when it's a bad, sort of weak, no backbone case to hold a middle ground position, right? Essentially, like, when are you being a quote unquote moderate in a positive sense, and when are you being a quote unquote centrist in a negative sense? I myself have really tried to, look into this on my own, and I think, at least on the surface, sort of superficially, I think what's going on is that ideally you want a position to be as synthetic as possible. And synthesis is not quite the same as centrism or even moderation per se. I'll kind of untangle this a little bit more. So, what do I mean by that? Okay, well, think about it this way. I'll use a couple examples. I'll use one that's a little bit more scientific, since I've already talked about like physics and cosmology on this channel a little bit. Even though I'm not an expert in those areas, I'm at least literate enough in those areas to use a couple examples. And then another one is a little bit more political. So we'll start with the physics one. For example, Einstein's theories came after Newton's theories, right? So when Isaac Newton was around, we just had Newtonian physics or Newtonian mechanics, which basically conceptualized time and space as being these sorts of absolutes or these rigid things. And then Einstein came along, and now a lot of people think that Einstein proved Newton wrong. No, that's too unnuanced of a way to think about it. Einstein did not necessarily prove Newton wrong. I mean, in a way he kind of did, but really Newton was still right in a sense, right? If we're just looking at the physics of everyday life, I mean, okay, yeah, to subtle degrees it operates in a sort of Einsteinian fashion, but it's so subtle and so negligible that really it's best to apply Newtonian physics to our understanding of sort of, everyday physics. But then once we go up, into space and we start looking at really massive objects, like black holes and planets, we really start to see the Einsteinian aspects of physics get more profound, they get more extreme, they get more drastic, right? So they're not so negligible anymore. Like, for example, when you're looking at an object as massive as this desk, okay, yeah, to a very subtle degree, it could be said that this desk is bending space-time to some very negligible degree, right? Like all massive objects bend space-time. It might be possible to say that that's what mass is. That's a little bit more philosophical, so I might be wrong there. But either way, objects with mass to some degree or another can be said to bend space-time. But when you're looking at an object that just has the mass of this desk, it's okay, it's not really going to bend space-time to any sort of measurable degree, right? You're not really going to see light bending around it or anything like that, unless we have really fine-tuned instruments, and maybe we could. Honestly, that's where I reach my limits on the subject of physics. It would actually be better to consult an expert on what I'm saying here because it might not be fully correct. But either way, generally what I'm saying is just that, objects with this small of an amount of mass are not going to be bending space-time to a significant enough degree to really be significantly detectable. But then you look at black holes and planets and objects which have, like celestial amounts of mass, and it's very easy to see light bending around them, right? I mean, we can see the gravitational lenses that are created by those sorts of astronomically large objects. And so you see how the sort of Einsteinian notion that space and time are not absolute, they're actually very flexible and very relativistic, that all becomes much more pronounced when you're looking at those aspects of the universe. Whereas when you're just looking at aspects of the universe like this desk, really, for all intents and purposes, you can think of this desk as being purely Newtonian. Now, yeah, okay, we could zoom into all the subatomic elements and it could start acting quantum rather than Newtonian. But again, that's the point, is that Einstein's physics and quantum physics, they don't necessarily prove Newtonian physics wrong. They just layer on top of it, right? So you think like, okay, we've got this mold and the core of it is Newtonian physics. Okay, we're adding more on top of that core, right? We're molding more on top of it. That's essentially what Einsteinian physics does and what quantum physics does, right? They build on top of it. Okay, so how does this relate to our subject of synthesis versus moderation? Okay, well, you could then say that Einsteinian physics is more synthetic than Newtonian physics because it includes Newtonian physics, right? Newtonian physics is just Newtonian physics. It does not include Einsteinian physics because, well, it was invented at a time where Einstein wasn't even born yet. But then later on, Einstein comes around and he stacks more on top of our understanding of physics. And so now we get a new level of physics which includes the old, right? So while Newtonian physics does not include Einsteinian physics, Einsteinian physics, on the other hand, includes both Newtonian and Einsteinian physics. So you see, it's more synthetic. There's a synthesis there between Einsteinian physics and Newtonian physics. Okay, but think of this. Think if you were a layman in physics. I mean, technically I'm a layman too, but again, at least I'm literate enough to be able to comment superficially on these topics. Picture if you were not even literate in these scientific subjects like I am. Picture if you were just a pure layman. Okay, if you're a pure layman and somebody holds up, let's say, 2 sheets of paper, one sheet of paper has all the details of Newtonian physics listed on it. The other sheet of paper has all the details of Einsteinian physics listed on it. If you're a layman, you're going to think, okay, maybe let's try and find a middle ground between both. Rather than choosing the Einsteinian sheet of paper, or rather than choosing just the Newtonian sheet of paper, I'm going to pick both and we're going to try and find some middle ground, find some compromise between the two, right? That's essentially how a layman would try to approach the problem and try and sort of find a position of moderation. And this would, in essence, make them a centrist. And I mean in the negative way, because here's why. If you're more of an expert, or if you're at least illiterate in physics, you're going to know that that's a very stupid move. It makes no sense to say, okay, let's find a middle ground between Einsteinian physics and Newtonian physics. You're going to know that's a dumb thing to say because you know that Einsteinian physics includes Newtonian physics, right? So if you're trying to go for the most middle ground position, you don't choose both sheets of paper, you instead choose the Einsteinian sheet. And by the way, let's say the Einsteinian sheet, because it has all the Einsteinian details, let's just say that necessitates it to also include all the Newtonian details. I should probably add that in there so that this thought experiment makes a little more sense. Obviously, if it just had Einsteinian physics, okay, yeah, you could make some case for the fact that we should still pull over the Newtonian sheet. But if the Einsteinian sheet has not just all the Einsteinian details, but even all the foundations for all those Einsteinian details, okay, well, guess what? all those foundations for all those details are going to be Newtonian, because Newtonian physics is the foundation for all of Einsteinian physics. So if it's going to include not just all the Einsteinian details, but all the foundations for those details, then it inevitably is going to include all the Newtonian details as well. But see, if you're a layman and you're just looking at both sheets of paper, you're not necessarily going to see that fact. So you're still going to think to yourself, okay, the most middle ground position is going to be taking both sheets of paper. When really, if you know what you're looking at more than a layman, you're going to know that it's actually better to just pick the one sheet of paper. Pick the Einsteinian sheet, because that's going to include both the Einsteinian and the Newtonian details. So ironically, this is where it gets very counterintuitive, is that in this example, the most middle ground position is not to actually take a middle ground between both sheets of paper. You see that? The most middle ground position is to be biased towards one sheet of paper. That's the ironic thing. The most unbiased middle ground position in this case is to be biased towards the Einsteinian sheet of paper. Because by being biased and picking that sheet of paper, you are, in a sense, picking both sheets of paper. Because the one sheet includes all the details on the other sheet, and then some. It includes more, too. So see, choosing the Einsteinian sheet, which also includes all the Newtonian details, that's a more synthetic choice. You see that? Where he's saying, okay, let's find some compromise or some middle ground between both sheets of paper, that is a centrist choice. That's where moderation becomes bad or weak, because think about it in a historic sense. Picture if our example of holding up two sheets of paper were to happen in a historic context. Picture if Einstein proposed his theories of general and special relativity, and instead of physicists adopting them and expanding their views of physics and their worldviews of the universe, picture if they instead went, well, we know Newtonian physics works, so let's try and find a compromise between Einsteinian physics and Newtonian physics. Now, technically this did happen, but again, once it was proven that, Einsteinian physics stacks on top of Newtonian physics as the foundation, it was natural to accept Einstein's new theories, because it was all there. It had everything packaged perfectly, right? That's why Einstein is regarded as such like an iconic genius, because he really found new theories that were not only brand new, they also packaged all the old stuff in them as well. That's what strong science looks like. Now, sometimes, old theories get proven wrong, but that's another topic for another day. In this case, they built on top of the old foundations, and that's what was so genius about them. They were simultaneously original and foundational at the same time. But picture if physicists were not able to see that. Picture if instead of accepting the new Einsteinian physics, they said, let's hold back a little bit. Let's try and find a middle ground so that we don't have to accept all of Einsteinian physics. Let's try and balance out, right? Let's try and balance out the Newtonian details with the Einsteinian details, rather than going full bore and accepting all the Einsteinian details. Think of what would happen if that did happen, which unfortunately it did not happen, but just picture if it did, we would have excluded a lot of important details of the new physics which Einstein brought to us, right? We would have excluded a lot of those details just so that we could feel comfortable with having some sort of balance between Einstein and Newton. This would have been a terrible thing to do, right? It would have hindered the progress of physics. Luckily, it didn't happen, though. Luckily, Einstein's new theories were tested, they were proven, and they were fully accepted, right? So physics gained a bias towards Einstein rather than being centrist and trying to go between both sheets of paper, proverbially speaking, which allowed physics to advance much, much further than what we had under Newton, right? So this is why centrism is bad, and this is why centrism is different than synthesis. See, synthesis allows for a more open level of progression. It is broader, right? It does not exclude certain details of Einstein's physics. It accepts them totally. And in doing so, also accepts Newtonian physics totally. Right? It's broader, it's more expansive, there's more progress there, there's more flexibility. Whereas with a centrist position, you're holding progress back. You're constricting it. So see, the irony is we tend to look at moderate or centrist positions as being the more flexible ones. They're actually not. They're actually much more constrictive. They are not flexible. If what you're looking for is flexibility, then what you should be looking for is synthesis, not centrism. Right? But again, remember, like the 2 sheets of paper example, sometimes the more synthetic position is a certain position. It means you have to take one position over another because the one position includes the other, right? So rather than trying to find a middle ground between both positions where you would actually hold back the newer, more progressive position, you need to step forward and just take the whole new position because it includes everything in the old position plus everything in the new position. You see? So that's what I'm thinking is the difference between synthesis and centrism. Now, let's look at the more political example. You know, like for those of us who live in the US, you know, I mean, well, racism has been a thing in every country, but I'll just use the US as an example for this video. Or at least I think racism's been a thing in every country. Honestly, it's possible that there have been countries which have never had instances of racism. I'm not quite certain of that fact, so you'd have to fact check me there. But certainly, either way, lots of countries have had a history of racism, but I'll use the US as an example. Let's look back at the times of segregation, where, you know, Caucasians and African Americans were going to school separately, they were living separately, they were in separate neighborhoods, taking separate buses, eating at separate restaurants, so on and so forth. Okay, then came along this idea of integration, where we want to combine the communities, right, have more diversity, so that we're getting more of a cultural mix in our schools. This can actually broaden education for reasons which I can explain in a future video. Actually, I can give a brief summary of why diversity is so important for education here in this video. You know how universities and academia, they're always looking to peer review certain ideas? And a lot of people who are against the notion of peer review will say, oh, well, how do you know that the peer reviewers aren't just biased and therefore filtering all the tests and interpreting them through their own biases? Okay, well, you want to know how academia tries to decrease the odds of that happening? Diversity. This is why academia is so, strongly emphasizing the need for diversity. They put such a strong emphasis on that because the more cultural backgrounds you get into academia, the more culturally diverse all the peer reviewers are going to be, and therefore the less of a chance you're going to run into a situation where they all have similar cultural biases and are trying to interpret a study in the same way. You know, like, okay, so a Christian scientist, yeah, maybe they're a peer reviewer and they're trying to bend the study to fit some sort of Christian framework, as just a general example. Okay, but if you have a Muslim professor thrown in there and they're also a peer reviewer, okay, well, what's going to happen then? They might try to bend it in favor of Islam, or if you've got a Buddhist professor or peer reviewer in there, they're going to try to bend it in favor of Buddhism. So see, now you're going to have different people pulling the study in all different directions, and they're all going to end up critiquing each other. And so that makes it more likely where you're just going to kind of get a dead average in the middle where it's not being interpreted one way or the other, because the Buddhist interpretation is going against the Muslim interpretation, which is going against the Christian interpretation. This is a hyper simplified example, but you get the point, is that when you have peer reviewers from different cultural backgrounds, different philosophies, different lifestyles, different beliefs, you're less likely to get into a troubled position of peer reviewers interpreting a study to their own ends. Now, yeah, it could still technically happen, but what I'm saying is the chances of it happening are decreased immensely. So that's why I don't understand why conservatives always make fun of academia. Like, oh, why do they care so much about diversity? That's why. There's a very practical, efficient reason for why they care about diversity. They're not just trying to look good, like, oh, look, we have all these African Americans in our school, or we have all these Hindus, or we have all these, East Asians. Like, it's not just an optics thing. There's a very specific reason for why diversity is pushed. It's so that the chances of corruption in peer review goes down, right? Those chances get decreased. Okay, so anyways, that's why diversity is generally important in education. So now let's go back to our political example. Back a few decades ago here in the US, you had people pushing for that kind of a thing, right? Integration between African American communities and Caucasian communities, where you would get them going to the same schools, working at the same schools, right? So again, more integration in academia, more diversity in peer review and research, and also just integration in general everyday life. African Americans being allowed to live in the same neighborhoods as Caucasians. So that was the whole idea of integration. Now, see, there were some people, it's genuinely the case, you can fact check me on this, there were some people who were taking the quote-unquote middle ground position between segregation and integration. This was a problem in the US back in the mid-20th century. I mean, figures like Martin Luther King Jr. and Malcolm X, they were explicitly speaking out against these centrists, because these centrists were, again, like the Einsteinian example, they were holding back progress. Right? They were saying, oh, okay, well, yeah, I like the idea of integration, but let's not just full bore accept integration. Let's not just allow the African Americans to flood into all the Caucasian schools, or allow them to flood into all the neighborhoods. Let's just kind of squeak them in there, right? Like, let's allow maybe like a few of them to, I don't know, attend some of the classes together, but not all the classes together, or let's allow the neighborhoods to be next to each other, but they won't be living together in the same neighborhoods. Like, they were really tiptoeing towards the progress that was being made. They were not full steam ahead. This has negative consequences because it does not allow for a fully granted level of equal rights to African Americans. That's why Malcolm X and Martin Luther King Jr. and all sorts of people were speaking out against it. So, see, people at the time didn't notice that, though. They really, really thought that the middle ground position, the most flexible position, was to find some compromise between segregation and integration. What we see now, looking back in history from the vantage point of where we're at in time, is that no, they did not actually have the more flexible position. The more flexible, expansive, inclusive position, which entailed more progress, was to just fully accept integration, right? Don't go between the Einsteinian paper and the Newtonian paper. Just pick the Einsteinian one. It's got everything that you could find on the Newtonian one and then some, right? If you just pick integration over segregation, okay, Caucasian people are going to have the same amount of rights that they did under segregation, but now on top of that, African Americans are also going to have those rights, right? So see, there's more equality, there's more equal rights. Caucasians don't lose anything, African Americans just gain something. Again, Einsteinian physics does not cause us to lose anything from Newtonian physics, it just causes us to gain more beyond it. So that's the more flexible position. That is the more synthetic position. Not a middle ground between segregation and integration, but integration alone, because it includes all the Caucasian rights that were there under segregation, plus the more equal rights for African Americans as well. You see, you're not losing anything, you are only gaining things. You're broadening, you're getting more expansive. So that's what is unhealthy about centrism versus what is healthy about synthesis. Now, yeah, there could be some exceptions in some cases where it's the other way around, where centrism could actually be healthy and maybe synthesis isn't, but I'm not going to be going into that in this episode. Just what I'm covering here is this general difference between synthesis and centrism and why one is generally, even if not always, but generally healthy while the other is generally unhealthy, right? Centrism hinders progress a lot of the time. It is not very flexible, it is not very expansive, and therefore it ironically is not very moderate or equal. Synthesis is true moderation. It is true equality, true flexibility, true expansiveness, true inclusiveness. You see? So don't always think that the unbiased position is the position that cuts down the middle. It's not always the case. A lot of times there's one position which is more inclusive than the others, and it is that position which is the broader, more flexible, more moderate position. It's the more synthetic one. So remember that moving forward. If that helps you in the ways in which you analyze information, let me know if you have any questions on this topic or any others. If not, I'll see you all in the next video. Until then, create a nice day.